We have considered government proposals to boost recreation activity at the new additional spillway site by providing boating facilities, shops, restaurants, hotels, and tourist companies. Our architects have also proposed of ferry, additional routes, railways, and other facilities for tourists to take first interest in this project. These are facilities which have been planned to provide it around the additional spillway, which can be used by and others. So, what we have planned in phase 2, the additional spillways provided would provide safety to the Hirakud Dam. The entire plan is to be carried out for an innovative approach which will not only ensure the safety but will at the same time boost tourism and recreation activities, attract tourists to this prestigious project. Thank you.
Thank you, Mr. For discussions. Once we complete our proper presentation phase, we actually haven't received the next presenter, Mr. Selvan's presentation. But if you are there, then we can have you. I would request you to again to be brief and conclude the presentation in about 12 minutes time.
Good morning, everybody. I am Selvan, working as a scientist in Central Water Research Station, which is in Kadakvasla, Pune. This paper is, little deviating from the flow what we were like. We are going to talk about the technology, what is to be for the drip, as well as there is another project, World Bank sponsored project. These are all as accessory instruments. Look, I will be concentrating on most of the education part. I am basically an electronic engineer. I would like to thank the director and the organizers for giving me an opportunity. So this is what I am going to cover here. Under the hydrology project, we have been identified as a central agency to test, calibration and certify the equipments before it goes for installation. So we are working on that particular model. So I'll be just brief about what facility we have and what we are aiming at. And then some of the instrumentation techniques. There are two parts. One is the dam health as such, which some private companies are covering, so I'm just not giving importance to the other instruments, which I'll be emphasizing here. In a modular approach, so far the instrumentation has become a proprietary of approach in the earlier experiences what we have. So we are trying to make it as a modular approach so that if a component fails, you need not replace the whole setup, you can go by a modular approach. Like the sensors, you have a data logger, you have a transmission system, and then finally you have an analysis and processing. So any part can be separately accessed and replaced. What is this SCADA? SCADA is my topic. It is supervisory control and data. It covers everything. Whatever we are going to talk in comes under a heading called the supervisory control and data acquisition. It talks about a sensor, data logger, communication and transmission system, and graphical user interface. Then of late, like everything can be put on a web so that centrally be monitored as well as controlled. So it's not on theory. We have developed in one of my last presentation in Patna, I was able to meet Dr. B.R.K. Pillai, who asked us to make a gate position indicator which can be monitored and controlled. So which CWPR has developed as a prototype unit, which will go for commercialization, by which you can able to monitor 0.1 degree of the gate movement so that the discharge can be monitored so that it can be controlled, and the unit calibration can be done sitting in Delhi through the web interface, which is in a working condition. If permits, we will demonstrate. So, what is that we are aiming? I'll just start a small graphical video. So this is what I'm address. So you have see, we have rain gauges and other additional sensors like water level, other things, and you have this is not GPS. This will be communication satellites. So you will rainfall, discharge, based on that information you communicate it to a communication mode, maybe it may be a communication satellite or GPS or INSAT. Then the data comes to the control room and you have a recorder at the dam wall. Based on the mathematical model or the concept, you operate the gate automatically or with the manual intervention. This is what we are aiming to address. Graphical, but the same thing we are trying to do it practically also. So now, from the earlier experiences, what we found is, so it's a little brief about our CWPRS.
I would suggest, using this being our National Dam Safety Conference, people are all aware about CWPRS. You go to the approaches for advising for implementing SCADA in a dam safety context, because that is the point of interest over here.
Right, sir. So I said the instrumentation I have classified into two. One is the access instruments, I'll just give you a brief what all the instruments we are talking about. So number one is water level. So in water level you have various of measuring it. This is shaft encoder type, which is very traditional and is comfortable with this. And submersible pressure type sensor, which is a replacement for the bubble that is being practiced now. Because the other disadvantage encountered in bubbler, and ultrasound is very commonly used, but it has a problem of not a problem. You have a beam width restrictions. The beam, it should not touch any connections or the dam somewhere. So that has been overcome by a radar technology. So underwater level, like we have put in 4 types of a float, radar, ultrasound, and type. Similarly for user level, and second parameter is velocity. The velocity and the cross section calculate your distance. So these are the very important parameters. So for velocity measurements, current meters, propeller, mechanical types, which has been now being by acoustic type instrument, popularly now being used. So various kinds of acoustic instruments, like side looking, you can, where it is able to have a board, you can put it in the side, or it can be fixed at the bottom. So whatever, there are multiple variants. So this the velocity with the cross-section profile you discharge. So it is another input parameter for controlling the distance from the gate, so which is for the other safety part. And there are non-contact. So these are all non-contact acoustic Doppler measurement, where you don't have an access to enter into the. You can fix sensors externally, and by the Doppler of the moving water particles, you will be able to measure the velocity and then the discharge. All this now the next component. So let us consider component A, which are all the sensors. Now the sensors comes to a second part, data logger, right? Most of the what happens, you buy a sensor some X amount and then you are forced to data logger, because the sensor doesn't give you data in a standard format. So this is what we are trying to standardize, and you are forced to buy a XY component which will read that sensor. So what happens as a project, if one you are forced to read the whole thing, which happened in. So we have to standardize. The sensor should give a standard output. The outputs internationally are voltage and frequency, right? So we insist on having a 20 milliamperes current output as a standard output, and that output is connected to a modem, take the data to a central. From the central server, you can able to talk to the sensor and then recalibrate program, identify the faults. So will operate in a protocol. So we are trying to modular approach so that a system will come into place. A SCADA system, a graphical user interface, by you can read, analyze, as well as control the sensor or calibrate the sensor sitting at a remote place to an extent possible. So which is possible if you have a modular approach. That is being emphasized. And apart from this sensor, you have ranges. They work in so I think most of us know this. There are different variants. Then you have other. These are all the instruments, accessory instruments. Then as I mentioned, data loggers, and here we have all the types of formats that data can support, right? So which is to be customized as per the user needs. So some of the advanced features, this is already explained you. You can see the battery status, see the power levels of the logger. You can recalibrate the sensor in case if there is an you can change the range, which is all possible and developed also, and the different variants of, and some sensor development also has been proposed due to I see some sediment classification requirements. So I'm trying to do that, and we have made a specs for. So I'll just take only the one page of it. These are identified. So this is made for project. Similar document made for drip. This is a velocity measurement. Basically, it measures the velocity, and you have to give the depth profile by across the profile. Yeah, cross section. Yeah. You measure at different points by your board and multiply by the at different cells, you get combined discharge. I can explain that. I can take it up, sir. You need to see velocity measured by putting it at side mounted, bottom mounted. That is to be done. But for the profile, you need to run across. That is mandate. You have to get the profile. Otherwise, if you have the profile, if it profile, it's fine. Otherwise, you have to run by some means, by putting a rope or assembly, or whatever way. That is. Sir? Which purpose? Function, it basically measures the velocity at the cross-section profiles. It has multiple things. Say if it is one center beam will calculate the then it classifies the depth into different segments. Then the cells will take it in, divide into multiple cells. At cell point, there will be a reflective medium get a Doppler shift, which gives velocity. So the velocity put at the overall cross section by the area gives you the discharge.
I think you can, because these specifications are going to be standard. And will need to be debated. Okay. We actually, start implementing them on the ground.
Okay.
So that would have been better had we discussed the specification.
Right. This is the calibration.
So now you can do your conclusions.
Yeah.
And
so this is the okay. So these are. So this to mention because Bharat Electronics has the facilities which is available for the other departments on a cost, like you can test from minus 80 degrees, 100 degrees, 200 degrees. I mean, all defense specifications also can be used. So these are whatever I have talked about, sensors which are accessory to the body. So these are the sensors which are installed in the body of the dam. So one of the case study what we are part of is at Indrasagar Dam at NHP. So your is up. You can type. So I'll give you the. So this is the final SCADA screen which for Narora barrage in Uttar Pradesh. So this is how the gate control on the input looks like, and finally the conclusions are selection of a SCADA system or the real-time system is based on it's a list and it can be customized. The project engineer is the best judge. He can help them in finding the right components. But finally the call is from the user. He needs knowledge about the components that can for a right. Testing and site visits help us make system instead of seeing only power presentation. Visit the sites, visit to the manufacturing facility, and arranging some demonstration